Using that information where x-intercept y equals 0, y-intercept x equals 0, we can determine in an equation, even without a graph, we can determine where the x and y intercepts are. So for example, if we want to find the x-intercept, we know that y equals 0, so we can just use this to plug in the equation. And we're gonna do 4x minus 6 times 0 equals 12. And we can solve for x. Because after we solve for x, then we'll have x comma 0. That's gonna be like the x-intercept. We just need to find out what x is. Okay, so let's solve for x. So 4x minus 6 times 0 is just 0, so this whole thing is basically gone. So 4x equals 12 divided by 4 on both sides. So we can solve that x equals 3. Okay, so that tells us the x-intercept is 3. And if we write it in a point, that's going to be 3 comma 0. That's the x-intercept. And for y-intercept, it's very similar. We just need to plug in this time x equals 0. So we're going to use that to plug in here. So we have 4 times 0 minus 6y equals 12. And 4 times 0 is just 0, so that's gone. Now make sure when you bring down this part, you would count the negatives as well, because the negative is part of this term. So it's negative 6y equals 12. And then we'll divide by negative 6 on both sides. So we solve that y equals negative 2. And that means the y-intercept is negative 2. Or if you write it in a point, it's going to be 0 comma negative 2. That's the y-intercept. So without graphing it first, we can actually find where the x and y intercepts are for this equation. And sometimes we can use that to graph. So like if we want to graph this line, I can just do, oh, okay, so one point, the x-intercepts 3 comma 0, okay, and then the y-intercepts negative 2 comma 0, so about right here. So that's gonna be my line. It's very convenient that way.